Hi, welcome to Why Engineering at the National Building Museum. Distance learning programs at the National Building Museum are supported by the United Engineering Foundation. So hi, I'm Yanitza, and one of the things we're going to be looking at is, ever wonder why buildings stand up, or how air conditioning gets into your homes, or have you wondered how skyscrapers end up being so tall? So in this program, we're going to look at how solutions to these problems are developed. Now, one of the things we're going to do now is introduce you to the National Building Museum.
It began with an idea to create a national home for the building arts and sciences, and at the same time, save an architectural treasure. This idea led to the founding of the National Building Museum in 1980. The National Building Museum is America's leading cultural institution devoted to the history and impact of our built environment. Fitting to its mission, the museum is housed in one of the most impressive buildings in America, featuring interior columns among the largest in the world. Here, visitors of all ages take part in exhibitions, public programs, and festivals, experiencing the wonder of architecture, design, engineering, construction, and landscape architecture, the industries that create our cities and communities. The museum is a forum for public conversation on critical challenges like sustainability, disaster resilience, affordable housing, and historic preservation. The National Building Museum, the place where ideas are born.
So as you have just learned in this video, the mission of the National Building Museum is to inspire curiosity about the world we design and build. In a similar manner, we're going to look at how we design the spaces that we live, work, and play in. Specifically, we're going to look at the collaborative nature in terms of how teams work together. To begin with, I wanted to give you a sense of how we're going to interact throughout this program. You're going to find that in this platform, at either the top or the bottom, you're going to find a chat feature. That's our main way of communicating, because I can't see you, but you can see me. So throughout the program, I'm going to ask you a few questions, and I'd like you to go ahead and type in your responses. Try to be as active as possible so that it's more interesting. In addition, if you can, go ahead and write your name after your comment so that I know who we're talking to. So to try that out, I'd like you to go ahead and go into the chat feature and let me know, where are you from? So who's on the program? So we have Karen from New Zealand, so that's very far. We have Denise from Hinsdale Central School in Western New York, Jessica from Oakton, and Alicia is a group from Massachusetts. Is anyone else on with us? We have Leanne from Virginia as well. Oh, Leanne is from Concord, California, and Suzanne is from Virginia, while Pilar is Tristan and Zane, who I believe we may have met before, from Baltimore, Maryland. And I think that's it. Okay, so the first question that I'd like to ask you is to look at, what jobs do you think are involved in the making of buildings? So go ahead and put in the chat, who do you think works on the making of buildings? Just go into the chat. Let's see. We have, Karen says engineers and architects, and Anika, architect, construction workers, engineers. Very good, Jessica. Construction workers, builders. Well, the people who actually work on building, like a supervisor, electricians, yes. So as you can see, there's a lot of people who have to work on buildings. Now, today we're going to focus on the role of an engineer. So we'd like you to let us know, what in the chat feature, what is an engineer? Okay. Any thoughts on what an engineer is? Someone who designs buildings, says Denise. Suzanne says basically an architect. Lauren, someone that designs buildings and structures. We'll take like one more answer. So now I'd like us to go back for a second and look at what our goals for today are. So today's goals are to learn about engineering. Sorry. Close. To learn about engineering and its disciplines with an emphasis on real-life applications. To get a behind-the-scenes look into the work of engineers with an emphasis on projects in Washington, D.C., and to engage in several quick challenges using the engineering design process. In order to do that, as we just started in the chat feature, we looked at what an engineer is. So now I'm going to give you a little bit more specific of a response of what an engineer is. So an engineer is a person who designs and builds complex products, machines, systems, or structures. Engineers want to know how and why things work. Now, part of that is looking at what engineering constitutes. So there's a lot of different disciplines in engineering. So engineering is the main category, but within that, 4 of the bigger subdivisions would be electrical, chemical, civil, and mechanical. And within that, there's even smaller specializations where you're looking at things like within civil engineering, which deals mostly with buildings. You also have structural engineers or environmental engineers. In a similar manner, you see mechanical engineers look at automotive engineering as well as aerospace engineering. In reality, there are dozens of possible specializations you can look at. Now, in this program specifically, as we look at what engineers work on, you see things like civil engineers design roads, bridges, and buildings, or mechanical engineers design machines that use force and motion, or electrical engineers design electrical equipment and systems. These are all type of engineers that we're going to be looking at in this program, because one of the ways that we are going to go through this program is that there's going to be a series of interviews with engineers that we did, and they're going to tell us a little bit about their inspirations and their process and what it is that engineers do and how they ended up with this as a career. Now, our first look is going to be at Dave from WSP, who was on the engineering team for the Smithsonian's National Museum of African American History and Culture in Washington, D.C.
I'm Dave Nichols. I work with WSP, and I'm an engineer in charge of commissioning, which is making sure the building works at the end of the project. From the time I was a little kid, I loved to take things apart and see why things do what they do. And the more I looked at it, the more that I thought that the engineering is all about solving problems, and that's what really sparked my interest. I started on the field into engineering almost by accident. The first thing I did as an adult was join the Navy. And then when I left the Navy, there was an opportunity to go back to school and learn something new. And while I was in the Navy, I was solving problems, but now I could apply to what I really wanted to do, and that was buildings. The main skills you need to be a really good engineer are, you have to have a logical thought process. You need to ask a lot of questions. Always ask questions. Why is this way? And then, how do I get from why is it this way to how do I make it the way I want it? And the process, it's all about the process. So you have to be organized, and you have to be an inquisitive person. One of the things that I wish that I had paid more attention to when I was in school was art, because engineers love things that work, but we also are putting these things that work into something that somebody wants to look beautiful. And just because it works very well doesn't mean it's necessarily beautiful. So today we're at the National Museum of African American History and Culture in Washington, D.C. This is a really cool project. It won a whole bunch of awards, but the coolest thing about it is the effort and the different phases that went into this. So first thing, of course, was design. And the design, the whole team, a lot of people, 50, 60 engineers in total probably, worked on the design for 5 years before the first shovel ever hit the ground here. Where we're standing right now is a little over 50 feet below grade. In Washington, D.C., that means we're below water, since D.C. sits on it's almost in a swamp. So we worked with the architect who didn't want to see my beautiful equipment up in the building to find a way to fit all of that below the ground. To do that, we had to keep the water out of the building, keep the river away from the building. So we worked with civil engineers, we worked with geotechnical engineers, architects, we worked with the city to make sure that we weren't going to ruin any of their infrastructure, and then the building goes up from there. But all the way through, everything an engineer does has to be coordinated with somebody. If it's the owner, to make sure they get what they want, it might be the architect to make sure that it looks the way they want, and then it's the people that have to maintain the building. The best thing about being an engineer is being able to drive around town and point to buildings and say, that one's mine, and that one's mine, and that one's mine. And then you think about all the cool things that it took before people actually used the building. I hope that this has piqued your interest, or at least made you wonder more about what engineers do. And if you're a person that is interested and likes to solve problems, it's very likely that you could be a successful engineer. So thank you for spending some time with us today.
So one of the things I enjoyed about this video is that we got an opportunity to get a behind the scenes look at a completed project. Now, one of the things that Dave mentioned in the video was the importance of the design process. And the reality is that even though engineers work on quite a few different types of projects, they do have something in common, which is their engineering design process that they use in order to come up with solutions. So we're going to go ahead and take a look at what that process is. Now, most engineers always start with, you have to define a problem. So the idea is that anything you do, you have to think about, what are you trying to solve? What is the problem that's here? What is the point of what you're doing? So you define a problem. That then goes into investigate. And this is really important because you should be able to do some background on what your problem is. Look at what's been done before. Look at what could possibly be done. Look at the resources. Get to better understand the topic of what you're looking at. Then that allows you to generate ideas that are better because you've taken the time to investigate. In engineering, they usually do work in teams. So during this brainstorming phase, it's really good to just sort of throw out a bunch of ideas in there. Some may be good, some may not be so good. But it gives you the opportunity to explore different options. Once you become more specific as to what you'd like to do, you'd start to look at planning. So the idea is that in this case, it's much more abstract because you're all over the place. But this is more concrete because you're now focusing on one or two solutions. This then allows you to produce a solution. Now, throughout this phase, one of the things that sometimes doesn't get done is evaluate. And evaluate is important because you may find that after you've gone through this process, this wasn't the best solution. So you start the process all over again. Now, in engineering, one of the ways that they evaluate is by creating prototypes. So they create a prototype, which is kind of like a model, where they look at, let's try this out, see if it's going to work at a smaller scale, so that way they're able to ensure that their finished product is at its most effective. Now, one of the things about the process is you're probably already using this in your everyday life, whether it's in school or at home, or even if you look at how your parents go through the day. So in the chat feature, I'd like you to go ahead and think about what are some examples when you use this design process. So you have another minute to think about your responses. Okay, so looking into the chat feature, I see that Angela uses it when you make Lego scenes. Oh, that's Anthony. And probably during writing, especially when you're looking at labs and STEAM challenges, as Denise points out. Annika mentions that my friend and I participated in the Minnesota Zoo's Design Challenge, and we used the design process when designing our project. That's great. So you've been introduced to how engineers and designers use this process. Any other times when you think you have been using this without realizing that that's really what you were doing? Okay. So we're going to go ahead and think about how can we use the design process by just sort of having a moment to do a brain boost. So if you have a notebook and paper, I'd like you to turn to someone else, whether it's a parent or a sibling or another classmate, and you're going to come up with a list where you think of how many uses can you come up with for something as simple as a tin can. So it can be anything you want. I'm going to give you a minute. So just think outside the box. I'm going to give you a minute, and then I'm going to want you to write in the chat some of the ideas of what you have. Now, don't worry about the answer, but if I've already said what it is, don't repeat it and come up with new ideas. So I'll give you a minute, and there you go. How many uses can you come up with for a soda can? Now, you can go ahead and start writing in the chat feature some of the things you've come up with in your list. Have you ever used a tin can for something that it was not intended to do? Or can you think of things you could do with it? So Annika mentions a telephone, a robot. Denise points out that you can make your muffler louder on a four-wheeler. Haven't tried that. But Anthony can use it as a car motor demonstration. Target practice, that is correct. To make a tower, a mini greenhouse in the garden. Suzanne points out you can use it as a musical instrument by blowing or tapping. It can be a paperweight. It can be something to sound like thunder. Karen mentions rocket, flower watering can, candles to conduct electricity, music, making a clicker. You guys came up with a lot of different solutions of what this could be. Some of the things I've looked at before were even things like you can make a lantern where you end up slicing it and you move it down. And even as you think about how you press it, it could even be something as simple as holding a candle because you've pressed it down. Now, we're going to go ahead now and look at how engineers use all these different steps to come up with solutions. So we're going to go ahead and join Elena at Canon Design so that we can look at engineering at work.
My name is Elena Honda. I'm a mechanical engineer at Canon Design. What sparked my interest in engineering was really outer space. As a kid, I had a teacher who told me all about black holes and how no one had ever traveled to one before. And that became my focus for many years, was to build a spaceship that could take us to a black hole. And as I got older, I realized that I just really liked the problem-solving aspect of engineering, and it could apply to anything that I wanted to do. I think the two biggest skills to become an engineer are problem-solving and communication skills. I use those every single day, and with HVAC engineering, it really changes every project. So you will have to come up with a new solution, and you will always have to be communicating with everyone around you. The other part that I think is really important is curiosity, because if you're not curious about your projects and what you're doing, you're not going to have better solutions and you're not going to grow. The most rewarding aspect of this job is the collaboration. As an engineer, you can really become single-minded and really focus on just the engineering, but here I interact with architects, I interact with graphic designers, I interact with electrical engineers, and it's very important that I have that communication and that I have the projects that are very interdisciplinary rather than just mechanical.
Hello, my name is Roberto Krusnimik. I'm an architect. I've been an architect for the last 26 years. I've done everything in my career, designing, doing technical documentation, and doing more project management. Right now with Canon Design, I do the operations for the office. So I do all the staffing and coordination between the teams. I typically work on very large projects where we have large teams and an immense amount of collaboration between engineers, architects, master planners, cost estimating, and the construction team. The good thing about having the engineers in the office is that we work closely together through the design process. From the first day of the project, we're working with the engineers to develop the basic system strategies and how the project will work in terms of mechanical systems, electrical systems, and plumbing systems.
All projects are going to require a design aspect where we use some modeling software, and it's going to give you these very beautiful images of just exactly what you need to put into a building. From there, you're going to go into construction, and you're going to go on site, you're going to see all the equipment you're putting in, and you're also going to see what the contractors are going to be purchasing. And then after that, as the building is being constructed, you will constantly be involved looking at everything going inside. And at the very end, there's something very important to our field right now, and that's the environment. And so we do like to track how our buildings are doing several years after they're done, just to make sure we're hitting every energy code we can. As you can see, it takes more than just an engineer to make a building work. And so thank you for coming to Canon Design, and I hope that you continue to wonder.
Now, looking at the work of Elena has made me think, wow, that seems interesting. I'd like to work as an engineer. So I'm going to do a quick demo. The ideas that I'm going to introduce to you, a fun project. You can try to work along just as a start, but what we'd like you to do is look at this so that way you can work on this after the project, after the program. So when I was thinking about a cool engineering project, I was looking at how you can use something as simple as newspapers and just roll them up in order to create a structural element that you can use to create towers or a table or a chair or other things. I've also seen this done where children, maybe younger siblings, created an actual fort that they could go in. Now, what I'd like you to do is to create the tallest tower that you can make. I've used the Eiffel Tower because it's something that I'm a little bit more familiar, but the idea is that you would take, if you happen to have some with you, you would take either newspaper or just regular copy paper. And you're going to end up folding it by going to the corner. You want it to be at an angle. You're going to go to the corner, and I'm going to go ahead and put it on the table because it's easier to control. But I'm going to try to make a really tight corner, and I'm going to start rolling. And throughout, make sure you're trying to keep it as tight as possible, especially in the beginning. Now, because you're on a table, it's going to get easier to roll. So once I get going, I'm going to be able to just slide over. So if I go a little bit more, now this is going to take a lot of practice. I find that it isn't until maybe the 10th version that it starts to look as tight as I want it to be. But having it in the table allows you to just slide your hands and move it along. Now, you would go ahead and use some tape if you have it, and you would now seal that piece. And the idea is that you would come up with a whole bunch of these. Some are better than others, but you would end up with a lot of these, and you start to think about how you can create a shape. Now, one of the things that we find is that, yes, you can use squares, but these are not as strong. What is stronger are triangles. So as you can see, especially as you're getting higher, this was okay for it to be a square. But if you look at a lot of skyscrapers, they start to get thinner because you're using more triangles. One of the things to look at in terms of that shape is Buckminster Fuller, F-U-L-L-E-R, was someone who is well known for the geodesic domes that he did. And they were based on these triangular forms, so they were much stronger. So just play around with it. The other thing is that once you've played around with it, after the program is over, we'd like you to post, if you really are proud of what you did, go ahead and post it on social media. So if you go onto Twitter or Instagram, make sure you use hashtag NBM Distance Learning, and we'll look through your submissions, and maybe we'll choose a couple to feature on our social media feed. So you're going to find that on the screen we have our Twitter and Instagram social media handles. Now we're going to move on and look at one more video. We're going to look at Waleed at SKA Engineers because he's working on the new International Spy Museum in Washington, D.C. So let's take a look.
I'm Waleed Choueri. I'm a structural principal in charge with SKA Structural Engineers, and I'm going to talk about the structural engineering of the Spy Museum today. You know, I've been a structural engineer for 18 years now. Initially, I got my interest in engineering sparked through really my father, who was a contractor. And I, through my childhood and high school, I always kind of worked part-time in the summers on job sites and always wanted to get into the construction industry, just didn't know how. So as I got into my undergraduate studies, which was at the American University of Beirut, I knew that I was going to get into a field of engineering. And that led to the need to get further education, and that's when I did my master's degree at George Washington University here in Washington, D.C.
Hi, I'm Dan with SKA Structural Engineers. I was a structural engineer on the Spy Museum project. I've always been very interested in how things work and how they're put together. I've always liked the Erector set, Lego, as I was young, and I always kind of knew that I was inclined to study math and science. I always got more excited in school, in math class and science class, doing experiments, learning how things work. So I just kind of knew that that engineering was a course for me.
Hi, I'm Brian Chun. I'm with Hickok Cole Architects. We are the architect of record for the Spy Museum. Spy Museum is a very exciting project. In my opinion, it is the most exciting building in all of DC. The building design is inspired by spycraft. Think about spies. There's cryptography, there's code breaking, there's all of this stuff, this analysis that happens inside the CIA, inside the NSA. You don't get to see any of that. So the big black thing on the right side, we call that the black box. That's what represents the cryptography side of spycraft. The other side of spycraft is just being hidden in plain sight. It might be two guys on a park bench exchanging nuclear launch codes or something. I mean, obviously that's from a movie. But this hidden in plain sight aspect of spycraft is represented by the glass on my left side here. This is the veil. Here's a great example, a great specific example of architects and engineers working together. We have a 65-foot tall piece of glass. Well, you know, there's rainstorms, there's windstorms, every now and then we get a hurricane. The wind pushes against the glass. If I had a 65-foot tall piece of glass with nothing supporting it, the glass would break. So what we need are a series of elements that take the structural load from the wind back to the building. So what we're looking at here are a series of Ys. The yellow elements are the structural stringers. The red elements are the structural columns that we see behind us. And believe it or not, everything is hanging from the very tips, like a whole series of yo-yos. So I'm not saying jump up and down and bounce around, but that is effectively the type of structural support we have here. If you like Minecraft, if you like 3D modeling, if you like creating virtual spaces, this is the job for you. We're standing in an atrium with a feature stair that was completed all in a three-dimensional BIM model. The BIM model, the building information model, is a three-dimensional computer model that we create, that we make sure all the pieces come together, all the pieces are the right size, all the structural members will take the adequate loads that we need them in order to perform over the life of the building.
Hi, I'm Jeff Guy with Clark Construction. What I do is I'm a different kind of engineer. So where Dan and Waleed designed the building, my primary job is to break that building down into a lot of smaller different parts that we can easily assemble, put together, and then set in place to build the building. The thing that interested me in becoming an engineer was trying to figure out how things work by taking them apart, figuring out the parts that were inside of it, and then figuring out if I put it back together, missing a certain part or adding a certain part or doing it a different way, whether it would still work or not.
This atrium area is one of the more challenging parts of the project. Combines a lot of different architectural designs and structural challenges to try to achieve them. The platform I'm standing on, as well as some of the stairways and this veil skin structure, is really mostly hung from the structure above us, and there's a lot of coordination and effort to get the analysis, design, and then construction of this structure completed. And as such, we nicknamed it like the jungle gym of the project, just because of the complexity of all the connections and the hanging structure. The most rewarding thing, working in structural engineering or the field in general, is probably seeing a completed product and knowing that you've had some input and some collaboration in getting that completed product done. Not too many fields have a visual completed product that you can drive by every day. So I'm glad I was able to speak to you today, and hopefully you got a little glimpse into the world of construction and structural engineering, and hopefully it may have sparked an interest in some of you that are more inclined to, liking a career along this lines, or you're good in math and science and not sure where to go. Engineering is always a great field to get into.
Okay, so I thought that video was really cool. And one of the things that I saw consistently was that these engineers were always wondering how things work. So I want you for a second to think like an engineer. Look around your classroom or your home, and what are you wondering about? Think about, let me know through the chat feature, what are you wondering about? So if you were an engineer, you're wondering about food. Karen may be hungry. So yes, you are hungry. Okay. Zane is looking at, how does the TV screen work? What else are you wondering? You're wondering about how they put the wires into the buildings, or how our smart boards were made. Good, Lauren. Suzanne is wondering, why don't the stairs fall through to the basement? And Angela wants to know, Anthony, how they make doors open with wheels on my entertainment system. Or Denise, how do they put lights in buildings? These are all fantastic things. So now all of a sudden, you're a little bit more curious about what's going on in the world that you live in. So we're going to go ahead and look at the fact that there's an explosion of STEAM. Now, STEAM refers to STEM, which is science, technology, engineering, and math. But we add A for art, so it's STEAM. And if you look around, it's giving us an opportunity to realize that there's a lot of creative careers that you can pursue. Engineering happens to be one of them. But you're probably doing things where you're taking things apart, you're putting them back together, you're reinventing how you use them. And one of the most common things that you may be using are toys. So we're going to go ahead and make a poll. And in this poll, I've mentioned 4 popular building toys. And you may be familiar with one, you may be familiar with all. But let me know, what is your favorite building toy based on the options that we've given you. Now, A is Legos, B is Tinker Toys, C is Erector sets or Meccano sets, and D is Kinetics. So we'd like you all to go ahead into the poll and let us know which one is your favorite. Let's see how many responses we have. Okay, we need 4 more. We have 4 of you. Just pick one, your favorite. And if you're not familiar with all of them, go ahead and next time you're on the toy aisle, look at some of these. Okay, we didn't get those 4, so we're going to go ahead and see what we have so far. The poll results show the suspense. I don't know. Well, Legos are definitely number 1. I do love Legos. They're fantastic and everyone has worked with them at some point. But definitely go ahead and try the others because they use other structural systems. So now we're going to go ahead and still using the chat feature, you're going to go back and I want you to tell me a little bit about how you're going to learn more about engineering after this program is over. Now, Alicia mentioned magnetiles, which is one way to learn more about engineering. I think they're really cool, and it's very similar to these, but they're magnetic. Now, Denise is going to try to take things apart and start to study them. Tristan is going to search Google. Definitely, there's so much information online. Read books and try kinetics, yes. The library is a great resource. You might try the newspaper tower idea. We'd love for all of you to try it. Annika mentions STEAM camps. Yes, there's definitely, especially now with summer coming up, there's a lot of camps you can attend. Karen is visiting the National Building Museum and the Spy Museum. Absolutely. Any other thoughts? So the reality is that, yes, there are a lot of books out there where you can learn more about engineering and the building trades. Rosie Revere Engineering happens to be one of my favorites. Now, you also could look at things like maybe there are apps that you're already using. Like Minecraft is quite popular. There's also a lot of you may be able to sign up for a Lego robotics class after school or during the summer. So the idea is just to get curious and go ahead and look at ways where you can learn more about engineering. Some of you may decide you want to be engineers when you grow up based on the careers that you've seen that these engineers have taken, but some of you may not. But regardless, what we want you to do is think critically. So now that the program is coming to an end, I wanted to know more about, are there any additional questions that you have? Now, you may have already put them in the Q&A feature, or you can go ahead and put it in the chat feature. So in the Q&A, I don't have anything, but I will go into the chat where I see that Pilar, one of the things she's going to do is talk to her uncle who's an architect. Absolutely, you'll find that a lot of your classmates or family may have engineers in part of what they do. Do you have any questions? Something that you wanted to know that maybe we didn't answer and we might be able to answer? So what is the main thing that chemical engineers do? So in my research, what I've seen is that chemical engineers, they manipulate materials. In some cases, they look at the qualities of existing materials, or they create new materials as they look at different properties that they can add to it. Karen is still thinking about food. Now, Anika wants to know what is the percentage of women engineers. The reality is that this is a field where we need a lot more women. So one of the things that's been done is that there's more efforts to look at how we can increase the numbers of girls who are interested in STEAM. So that's definitely something that you should look at because we want that diversity of experiences and just to be able to bring other voices in. Are there any other questions? Well, at this point, we'd like to thank you for joining us at Y Engineering. One of the things that you can do is, if you happen to be in DC, come and join us at the come join us at the National Building Museum. Now, before you go, we would like feedback so that we can further improve our distance learning programs. So in the chat feature, I want you to go ahead and think about 2 stars and wish, which may be something that you're already using in the classroom. And the idea is tell us 1 or 2 things that you learned or that you enjoyed, or that think about 1 thing that you wish we had done or we had improved. So in the chat feature, I want you to give me some ideas as to what I can do next time. In fact, some of the parents and educators will be contacted after the program because we're looking at doing short interviews and finding out how your children or your students reacted to the program and what did they think about it. So you guys should talk amongst yourselves. Karen enjoyed learning about engineering careers. Absolutely, that's one of the things that we thought was particularly interesting. Denise enjoyed the interviews with the engineers, especially how the different engineers collaborate. Angela likes using newspaper to make a structure and learning about the Spy Museum. And Suzanne enjoyed engineers talking and telling us about their jobs. So several of you have mentioned that the engineers were particularly interesting. It was definitely one of my favorite things to look at. Now, are there things that you think we could have done to make it better? What could we do next time as we continue to improve our programs? Zane enjoyed learning about building design. Karen's child is still thinking about food. You need to go eat and think about how your food came to your table. So Angela would like more time to respond for slow typers. So we'll slow down next time. Thank you for letting us know. And maybe a little bit more hands-on online projects. One of the things that we are going to do is that we're going to look at opportunities to give you more post-program opportunities to look at what can you do. YouTube is definitely a great resource to look at other demos. Introduce the paper wrap structure activity later in the session. And Tristan liked how they planned the design of the building. Okay. Now I have another minute. Are there any other things that you think you really enjoyed or you really want us to do more of? Is there something that you feel that you wanted to learn? You'd like more resources that I mentioned to follow up? Absolutely, that's definitely, we're gonna look into that. And Pilar enjoyed the interviews. Well, at this point, our program is ending, so we're going to go ahead and thank you and say goodbye.